We are going to discuss the extraction of organic compound and purification methods. An organic compound is extracted from a natural source or it is lab made, but it does contain certain impurities. So, to purify and get the product we need, we have several methods of purification. So, we are going to elaborate on them. So, what are the methods? Methods are listed out here. So, first method First method is sublimation. Next is crystallization, distillation, and within distillation you will have variety of distillation methods such as fractional distillation, steam distillation, vacuum distillations, depending on what the criteria is. Sublimation, for example, if we have to see where sublimation method will be used. So sublimation will be used wherever impurity or the substance is sublime in nature. What does sublimation mean? Sublimation means conversion of a substance from solid state to a gaseous state. So if any of our product is having this property, that means it can convert directly from solid to gas, then what we do, out of mixture of multiple things, the substance we need, it will vaporize and get converted into gaseous state, and we will collect those vapors so that impurities will remain in the mixture and vaporized and then condensed substance we get as a pure substance. So sublimation is usually used when we have certain compounds such as camphor, which is volatile in nature, we have anthracene, or we have dry carbon dioxide. So for these, because they have a tendency to easily vaporize, they are separated by sublimation method. All right. Next, you have crystallization. Crystallization is basically a method which is used when there is difference in solubilities. So something that is less soluble will precipitate out or crystallize easily in comparison to something that is more soluble. So something which is less soluble will precipitate out and crystallizes, and we get solid substance in this method. Next is distillation, and distillation we have this method is basically for separation of substances which have huge difference in boiling points. If the difference in boiling points is big enough, then we use distillation. Now, when boiling point difference is less, we use fractional distillation. There are certain compounds which decompose at their boiling point. So, for separation of such compounds which decompose at their boiling points, we use steam distillation or distillation under reduced pressure, which is also called as vacuum distillation, could be used. All right. So there are variety of distillation methods. Next method we are going to discuss is chromatography. Chromatography is used for separation of colored substances or for purification of a mixture which contains multiple components, right? So chromatography is a modern technique. It is basically divided into two categories. One is adsorption chromatography, another is partition chromatography. So adsorption chromatography is further based on adsorption phenomena. Adsorbate adsorbs on the adsorbent. Adsorbent is mostly silica gel or alumina, right? So adsorption chromatography can further be divided into column chromatography, where we take the components in a test tube, where you will have silica gel at the bottom. If I show you column chromatography setup, it will be something like this. It will be something like this. Something like this. I'll make it a bit more precise. Now, what happens is we have silica gel over here. This is closed. This is closed. This is silica gel. Now, on top of it, we put the mixture. We put the mixture which we need to separate. This has A plus B, right? We need to separate them. Now, from the top, we will place a solvent. At the top, we will have a solvent. This a solvent. It is called eluent or mobile phase. This is mobile phase. This is mobile phase. All right. So solvent is placed at the top, and you have a mixture A and B, and this is silica gel. Silica gel is used as a stationary phase over here. There is a stationary phase over here. When you put a solvent from the top, what happens is A and B dissolve in the solvent and they start coming down. And silica gel acts as a layer where adsorption happens. So, if A has greater adsorbing power, then A will be separated. A is separated here and B will go down. In this way, A will adsorb first and B will go little bit down. So, on the basis of adsorption, A and B are separated out. So, adsorbing power, I can say absorbing power for A is more because it is getting absorbed first and B is going down. So, adsorption power of B is less. So, in this way, we can separate A and B using chromatography, and such chromatography technique is known as column chromatography. Similarly, we can have thin layer chromatography in which we take a plate, a glass plate, on top of it we put a layer of adsorbent and we place a strip or a line which is called baseline. Over that we'll put a dot that contains mixture and we put that strip into the solvent, and solvent gradually goes up by adsorption and separates the mixture components. So, this is another way of adsorption chromatography, and in this way where solvent is coming from the downside, this is known as um, thin layer chromatography, and when solvent is coming from the top, it is called as column chromatography, and when it is solvent is coming from the downsides, it is known as thin layer chromatography. And partition chromatography involves the use of chromatography paper. So partition chromatography is another name for paper chromatography. Paper chromatography is one example where partition chromatography happens, and the phenomena is basically capillary action. In partition chromatography, basic phenomena is capillary action. All right. So this is it. We have explained all the types of separation methods. All right. Thank you.